The story of blackbody radiation began in the late 19th century, when scientists tried to understand how objects emit and absorb heat energy as electromagnetic radiation. A blackbody is an ideal object that absorbs all incoming radiation and emits energy only based on its temperature, not on its material or surface. The radiation it emits spreads over different wavelengths and has a characteristic distribution. Classical physics, particularly the Rayleigh-Jeans law, attempted to explain blackbody radiation. It predicted that as the wavelength decreased, i.e., higher frequency, the emitted radiation would increase without bound. This led to the so-called ultraviolet catastrophe, where the theory predicted infinite energy emission at short wavelengths, which was clearly not observed in real-life experiments. In 1900, German physicist Max Planck solved this problem by introducing a groundbreaking idea. He proposed that electromagnetic energy is not emitted continuously, but in discrete packets called quanta. He showed that the energy E of these packets is proportional to the frequency F of radiation, given by the equation E equals hf, where h is Planck's constant. This marked the beginning of quantum theory. Planck's theory introduced the concept of energy quantization and linked it directly to oscillating frequency. The higher the frequency of oscillation of a system, such as atoms or molecules vibrating, the more energy is carried by the emitted radiation. This model successfully matched experimental results and eliminated the ultraviolet catastrophe. Oscillating frequency is central to blackbody radiation. At higher temperatures, atoms vibrate faster, emitting radiation with higher frequencies, shorter wavelengths, and greater energy. The spectrum of radiation shifts with temperature. Hotter bodies emit more in the visible or ultraviolet range, while cooler ones emit in the infrared. Some examples of blackbody radiation include the sun. It emits across a broad spectrum, peaking in visible light due to its high surface temperature. Incandescent bulbs. The hot filament emits thermal radiation, mostly in the infrared and visible range. Heated stove burners. They glow red, indicating emission in the lower frequency part of the visible spectrum. Infrared heaters emit mostly in the infrared range, corresponding to lower frequency and energy. Planck's theory of quantized energy revolutionized physics and paved the way for modern quantum mechanics.